Losses in transformers. When we consider a transformer, we need to remember the construction which it is made up of. Okay, firstly, we've got copper used to create the windings. So the first loss is because of the copper. Copper loss is also called winding resistance. Okay, now we have to remember that because we're using copper and current is flowing through these coils are going to cause resistance, which will decrease the efficiency. Second type of loss is my core losses. Okay, core losses is because of the soft iron core that we are using. Now this causes two problems. Number one, it becomes magnetized, and then when this polarity changes, that polarity has to be cancelled and it has to become polarized in the opposite direction. This is called hysteresis, because I have to demagnetize and remagnetize that core. Secondly, what happens is, because this is a conductive material, as this magnetic field that is created by the primary and the secondary coils, as it cuts through the core, it causes a current to flow inside of that core, and that core is called, or that core current is called eddy currents. So core losses, to summarize, is hysteresis as well as eddy currents. Okay, now also, just by the way, the eddy currents does cause this transformer to increase in temperature, and as that increases in temperature, the resistance of the copper will also increase. Next, we've got magnetic flux losses. Or field leaks. Okay, so what happens is, sometimes it happens that too much current flows, and as a result the core can't handle all those magnetic fields. So some of the magnetic fields created does not meet both coils, and that causes a loss. Okay, this field leaks is a loss of the coupling coefficient. Next, this one is actually very uncommon in a normal transformer, and this is called winding capacitance or dielectric losses. Now, dielectric losses only occurs at very high frequency. So basically what happens is, at a very high frequency, those windings will cause a capacitance to form between the individual loops. Now what happens there is, those capacitors literally serves as an AC bypass for the current that wants to flow through the coils. Okay, when it comes to advantages and disadvantages, advantages of transformers. Okay. Advantage of transformers is I can change my voltage by increasing or decreasing it in a very simple manner, and by changing my voltage I will also change my current. We'll look at the calculations at a later stage. Transformers are used in a wide variety of applications, which includes power transfer, electric noise filtering, frequency oscillation, impedance matching, and so forth. The primary turns and the secondary turns are insulated in terms of electricity. Okay, what that means is there's no electrical connection between the primary and the secondary. As a result, we use it to isolate multiple circuits. Depending on the configuration, we can use them in motor vehicles, in the auto transformer, and we can also apply tapping of the transformer to remove or only get a smaller portion of the output. Disadvantage: of transformers is it only works on AC circuits. It cannot work in DC. Transformer, because of the coils, is large and bulky. Okay, it's heavy. Due to the materials used and the size of the core, they are limited when it comes to the frequency that they experience. Power transformers can only operate at low frequencies. Large transformers need to be cooled. Cooling needs to be considered. Transformers are expensive due to the materials that is used and the actual manufacturing process, and it's difficult to construct. Okay. When it comes to different types of transformers, those transformers will be determined by the need of what we are going to use. Types of transformers. Firstly, we're going to look at the circuit symbols. It's the easiest way. All transformers in essence look exactly the same. Okay, it represents the primary as well as the secondary coils. Now, if there's no lines in between there, it means that it is an air core, which basically just means the two coils are placed very close together. Okay, for a soft iron core, we represent a transformer with the two solid lines. If I replace those two solid lines, if I replace those two solid lines with dotted lines, then it represents a ferrite core, which is a very hard iron. Okay, when it comes to transformers, the ideal transformer, it's 100% efficient, which means there's no losses. Magnetic flux doesn't saturate the core material, and the transformer ratio equation applies to all loads. Okay, when it comes to the auto transformer, what we basically look at is a situation where we've got one coil and we've got a second coil, but these two are connected together. Now basically what that causes is all these loops will induce a voltage into my secondary side. Okay, so basically this will come from the starter from the starter battery, and this will then go to the starter motor, okay, in order to step up the current flow. My center tap transformer, I've got a primary turns, secondary turns, let's say this is a soft iron core, and we've got a tap that connects out in the middle. That means that that voltage and that voltage is going to be equal to each other. The only difference is that 0 volts, and that's plus V, and that is minus V. Voltage will switch. If that center line becomes my reference, this is my part2 transformer. Okay, with a tap transformer, if this is exactly in the middle, it's called a center tap transformer. If that point is above or below, then it is just called a tapped transformer. It is possible to have multiple taps on the secondary side of the transformer. I've also actually seen taps on the primary side of the transformer as well. Okay, finally is your instrument transformers. Okay, instrument transformers are used in power generation, where we're generating hundreds and thousands of volts, but we don't have voltmeters that are able to measure that high. So what we do is we step down that voltage, or we step down that current, in order to measure how much current and how much voltage is being generated. So to make it clear, we've got a voltage transformer and we've got a current transformer. Any transformer will automatically convert voltage and current. We'll get to that when it comes to the ratio calculations, but with the voltage transformer we're using primarily because we want to transform the voltage value. So what we will do is, on our primary side we will have a whole bunch of turns, and on my secondary side I will have a lot less turns. So if I've got a big voltage on the primary side, I will get a small voltage on the secondary side. When it comes to current transformers, on the other hand, we will have a small amount of turns on my primary, and I will have a large amount of turns on the secondary side. So as my large current flows through the primary, I will have a very small current on the secondary, so that I can actually measure. Okay, it is important that on this side you connect a bypass switch that needs to be disconnected before, or needs to be closed before you can connect your meter, in order to serve as protection device.